Good day everyone. Welcome to our new video in Statistics and Probability brought to you by VNHS Senior High School Mathematics Group. Again, I am Sir Neil, and on this video, I will be discussing about our fourth lesson, which is Probability Distribution of Discrete Random Variables, Part 3, Computing Probabilities of Random Variables. Now, are you ready to learn? Very good. So, for us to start, let us recall that in illustrating discrete probability distribution, we compute the corresponding probabilities for each values of a random variable by counting the number of repetition of the value divided by the total number of outcomes. So, to fully understand this one, let us have our example. So here we have the possible outcomes in our previous videos. We have HH, HT, TH, and TT. And the values for a random variable, X, which is the number of heads, for HH, that is equal to 2, HT is equal to 1, TH is equal to 1, and TT is equal to 0. Now, if we try to compute the probabilities in a probability distribution, we have this random variable X and the column for the probabilities for each random variable X. So, the values for a random variable X will only be the unique values here. So, that would be 0, 1, and 2. Now, the values for each variables here, for example, let us have X is equal to 0, the probability that your X is equal to 0 is equal to, we only need to count the number of repetitions. So 0, how many zeros here? We only have 1. And then divided by the total number of outcomes. So the total number of outcomes here is 4. So that would be 1 over 4. Or it is equal to 0.25. Now, we do the same to the random variable X equal to 1. So, the probability of X equal to 1 is equal to, we count the number of repetitions here. So, 1, 2, divided by the total number of outcomes, which is 4. So, 2 over 4 or 0.5. And the same with X is equal to 2. The probability that your X is equal to 2 is equal to 1/4 or 0.25. Now, if we are asked to illustrate the histogram of our probability distribution, then it will look like this. Actually, histogram is more like a bar graph showing the probabilities for each random variables. As you can see, in the vertical axis, that is the probabilities corresponding for each random variable X here on the horizontal axis. So you just do it like this, okay? Take note that the sum of all probabilities in a discrete probability distribution is equal to 1. If you will add this one on this given probability distribution that we have, this will be equal to 1. So 0.25 plus 0.5 plus 0.25 is equal to 1. It is always equal to 1. It means that if it is not equal to 1, then it is not a discrete probability distribution. Okay? So, let us answer this question. What if we are to compute probabilities of a random variable with a given probability distribution? In that case, let us take our example 2. So, in our example 2, given the probability distribution of X, or the number of eggplants attacked by worms, so X, the values of our X is 0, 1, 2, 3. And the corresponding probabilities are for x is equal to 0, that is 0.125, and for x is equal to 1, that is 0.375, and for x is equal to 2, that is 0.375, and for our x equal to 3 is equal to 0.125. So, we are tasked to compute the probabilities of the following. So, let us take number 1. This is read as like this. Probability of x is equal to 0. It also means, in layman's term, that what is the probability that the number of eggplants attacked by worms is equal to 0. So, if you will see, you only need to determine the value of this, you only need to get the probability corresponding to 0. So, that would be our probability of x is equal to 0 is equal to, okay, very good, that is 0.125 because it is here indicated. Now, let us take number 2. Suppose we are asked to find the probability of x is greater than 1. In layman's term, what is the probability that the number of eggplants attacked by worms is greater than 1? Meaning, we only need to see the corresponding probabilities for x greater than 1. That is 2 and 3. So, we only need to include these probabilities, which is 0.375 and 0.125. Which means that our probability x is greater than 1 is equal to, okay, very good, that is 0.375 plus 0.125. Now, if we add this one, that is equal to 0.5. So, it's as easy as that. Now, let us take the third example. Suppose we are asked to find the probability that our x is less than 3. It means that what is the probability that the number of eggplants attacked by worms is less than 3. So, again, we follow the same process. X is less than 3. So, we determine the numbers less than 3 here and add all those probabilities corresponding to those values. So, we have the numbers less than 3 is 2, 1, and 0. So, we add our probability of x is less than 3 is equal to 0.375 plus 0.375 plus 0.125, which is equal to 0.875. Now, lastly, we are asked to find the probability that our x is less than or equal to 1. It means that we need to include 1 because it is less than or equal to 1 and the numbers less than 1. So, that is 1 and 0 for the values of x. And the corresponding probabilities for our 1 and 0 is 0.375 and 0.125. So, we only need to add this one. So, our probability of x is less than 1, less than or equal to 1, is equal to 0.375 plus 0.125, which is equal to 0.5. So, it's actually quite very easy to determine the probabilities of a random variable with a given probability distribution. You only need to add the corresponding probabilities for those determined by the question, as we have done here on the examples. So, are you ready to test your understanding about computing probabilities of a random variable with a given probability distribution? Great. So, let us have computing probabilities. So again, we'll now have our supplemental activity 3. I want you to copy this one and answer it in your activity notebook. So, this ends my presentation. Thank you very much and God bless us all.